Hello, everyone. So for this project, I'm going to break down the four focus sequences we can choose from a structural engineering major. It is, I think, a really unique part of our department because we learn to design any structure, but we get to specialize in what we love most. First, we have civil structures. I think it's the city's backbone. But in this slide, you'll see on the left, there's a building with cracks in the wall. That is where civil structures engineers act as a detective. They do forensic engineering to figure out why structures fail. One of the famous cases we learned about was the Tacoma Narrows Bridge, which you can see here. It collapsed due to aerodynamic flutter back in 1940. Engineers studied that failure, and it completely changed how we design buildings and bridges today. That process of learning from failures is a huge part of this field. Second one we have is geotechnical engineering, which I think it is the ground beneath us. This is all about what's underneath our structures. On this slide, you will see really interesting how geotechnical engineers take these samples to understand different layers of soil and rock because you can't design a foundation if you don't know what you're building it on. Is the Leaning Tower of Pisa, shown on the left. It is leaning because of the difference in settlement. The soil on one side was weaker and compressed more. This is exactly the kind of problem geotechnical engineers are hired to predict and prevent. Another issue is soil liquefaction, actually pretty prevalent in San Diego. It shows how during an earthquake, solid and sandy ground can easily turn into quicksand. It's shown on the right. We have aerospace structures. I think it is the engineering for the skies. First thing you learn is to balance these four forces, which are lift, drag, thrust, and weight. For an aircraft to fly level, lift has to be equal to weight and thrust has to equal drag. This simple balance dictates everything around the design. On the slide before, we have a picture of carbon fiber, which is one of the materials used to make planes light but strong. This isn't like one specific material. It is fabric set in resin, which is woven, so it is like really lightweight and strong, but it's expensive. On the right here, we have a UAV drone. Not just about passenger jets. We can also use it for military to inspect bridges after an earthquake. Lastly, we have SHM and NDE, which I think are the structural doctors. Think of them as the doctors for short structures. Instead of waiting for a crack to appear, we have sensors all over the bridges and buildings to constantly monitor its health. The key difference between them is NDE is like a specific medical test. You go out, hit the bridge with a hammer, like see it, like shown on the picture here, where a bridge goes by, no, a bus goes by the bridge. And all these sensors show how the vibrations are used. While on SHM, it's like continuous tracker of constant flow, like regular traffic going through a bridge. And they're permanently installed, constantly like giving out data to ensure safety. So one of the main focus sequences that I want to learn is aerospace structures. Seeing just planes like the 787, knowing its wings are made from composite materials like carbon fiber, it's just incredible to me. Like just the challenge of weight and gravity and having lightweight material, being able to just go fly and like be a transportation for many individuals. And I actually want to make a design that may work in the future. It just feels like the ultimate application of structural engineering.